Now we're simply going to look at some examples so you can see how to use this. If you look at page 115, we're going to look in exercises 3 through 16. It says, find the values of the trigonometric functions of the angle in standard precision whose terminal side passes through the given points. For exercises 3:14, give answers in exact form. For exercises 15 and 16, the coordinates are approximate. Okay, so let's just take a look at number 4, and I want to review a little bit with you about graphing. Remember that when you look at a graph, this is the x-axis, this is the y-axis, and an ordered pair is an alphabetical order. So if in number 4 we were going to graph the point 5, 12, this is the x value, this is the y value. And when you graph something, you go out on the x value, the number that it gives you. So if it gives you a 5, you go out to 5. If it gives you a -4, you go out to -4. So these are the positive numbers. These are the negative numbers. And then the second number is the y value. And after you get to the x value, that tells you where you go for the y value. So if I were to go out to 5 on the x, I don't draw a dot yet. I wait until I go up 12 because it's positive. If it had been a negative, I would go down 12. So I'll go out 5 and up 12. So let's say I went up 12. And that's where I put my dot. If it had been a -12, I would go down 12 and I would put my dot right there. So in this one, I'm going out 5 and up 12, and then I draw from the center a line segment to that dot. And when you draw these, you will only draw shapes that look like this butterfly. You only draw from the dot to the x-axis. So if your dot's up here, you make the triangle going down this way to the x-axis. If your dot's down here, you'll be drawing a line up to the x-axis. If your dot's here, you'll be drawing down to the x-axis. So you'll have this triangle. If your dot's down here, you'll be drawing up to the x-axis and you'll have this triangle. The angles that you're looking at are only the innermost angles. So you could have a triangle that looked like this and you'd be looking at this angle. If you had a triangle that looked like this, you'd be looking at this angle. If you had this triangle, you'd be looking at this angle. And if you had this triangle, you'd be looking at this angle. And notice that my shape looks like a butterfly or a bow tie. You will not have angles that look, let's say I have a dot here, and I draw my line segment from the center to the dot. I will never draw a triangle over to the y-axis. I always draw the triangles down to the x-axis. So when I draw this one, I draw down to the x-axis. Notice that it forms a right angle when you do that because it's a straight line segment. And I have gone from the center over 5. So this distance is 5. From the 5 up to the 12, I've started at the bottom and I've counted up 12, so this distance is 12. So I now have a triangle that looks like this. From the center, I drew a line segment, then I drew one down, made my triangle look like this. I went out 5 and up 12. Make sure that if this number had gone out to -5, you label it with a negative. If this one had gone down, label it with a negative, because not only is it direction, but it tells us position. So we want to make sure that we get the signs right. This number over here will always be the hypotenuse. It is a measurement, it's a length, so we always get a positive number no matter what these numbers are. So if I were going to solve for that number, remember that we have the Pythagorean theorem, which is c² equals a squared plus b squared. And in this case, remember that the c is the hypotenuse, so in this case, c is r. The legs, it doesn't matter which one you label, a or b, so I have 5 squared, and I'm using parentheses so that if I had a negative, it would end up being a positive. So make sure that when you do the math, you use a parentheses. So I will have r squared equals 25 plus 144. So I get 169, which is r squared. And remember when we solved this, we took the square root of r squared, and that's how we got r. So in this case, r ends up being 13. So I'm going to put a 13 over here. That's my hypotenuse. So I've solved everything on my triangle now. So now I have a triangle that looks like this. Five, 12, and 13. And my directions ask me to find the values of the trig functions for the angle in standard position. And we're going to find all 6 of them so that you can see what we would do. But we're going to do the sine. Remember that sine is side opposite over adjacent. And remember that we're always doing that innermost angle. So it's the one that's closest to the origin. Remember, if I had the triangle over here, it would be this one. If I had the triangle here, it would be this one. Triangle here, it would be this one. Our triangle happens to have this one. So side opposite is 12, and hypotenuse is 13. So my sine is 12 over 13, and of course I would reduce it if that fraction could be reduced. And I am going to do a video of just little key things to remember on your calculator as well. Cosine is side adjacent over hypotenuse, so here's my angle. The side that's beside it is 5 over hypotenuse. Tangent is side opposite over adjacent. So again, here's my angle. Opposite is 12. Adjacent is 5. So those are the 3 trig functions. If I go over here and I do cosecant is the reciprocal of sine. So if I flip it upside down, I have 13 over 12. Secant is the reciprocal of cosine. So let's flip it. And cotangent is the reciprocal of tangent, so let's flip it. So that's your those are your basic steps for finding the 6 trig functions.